So today I'm going to be teaching the skill I can graph a rational function to show key features, and the key concept is how to find key features on a graph. So the first problem I'm going to be doing is x minus 2 times x plus 1 over x minus 2 times x plus 5 times x minus 3. So first you are going to find the x-intercept, and to do that, which is the point or points at which the function touches the x-axis. So to do that, you just look where it touches or crosses over the x-axis, and that would be right here at -1, 0. So then you're going to find the y-intercept, which is the point at which the function touches or crosses the y-axis. So for this one, you're just going to look where it crosses the y-axis, and that is right here at 0, -0.067. And then you're going to look for holes, or a hole, which is where the function has a break, or the x value where the graph's y value is undefined. And these only occur when the numerator and the denominator share a factor, and they do, x minus 2. So you're just going to look where x equals 2, and that is going to be right there. So, and then you're going to find your domain, and the domain is all of the x values of a function. So for this domain, you go from -infinity, and you go to -5, and then you go from -5 to 3, and then from 3 to +infinity. Then you're going to find your range, which is all of the y values in a function. And the range is going to be all real numbers, because it goes from +infinity to -infinity down there. Next, you're going to find your asymptotes, and asymptotes are lines that a function approaches as x approaches positive and negative infinity. So there are two types of asymptotes, vertical asymptotes and horizontal asymptotes. This one has both, and the vertical asymptotes, the first one is x equals -5, and you can see that by looking here. And then it also has x equals 3, and you can see that here. Next, you're going to find your horizontal asymptotes, and that is y equals 0. And right here, y does equal 0, but this middle part does not count toward the asymptotes. Next, you are going to find your end behavior, which is how the function behaves as it approaches infinity. So, as x approaches -infinity, y approaches 0. And as x approaches +infinity, y approaches 0 as well. So I have one more function that I'm going to show you how to do, and it is x plus 4 over x plus 3. And so first you're going to find the x-intercept, and again you just look where it crosses over the x-axis, and that is going to be right there at -4, 0. Then you're going to find your y-intercept, and you'll just look where it crosses over the y-axis. That is 0, 1.3 repeating. And there are no holes because the numerator and denominator do not share any factors. Then you're going to look for your domain, and your domain goes from 0 to -3, and then from -3 to infinity. Then you're going to find your range, and your range goes from -infinity to 1, and then from 1 to infinity. And you're going to find your asymptotes. So first, vertical. You can see that the function approaches -3, but never reaches it, and approaches -3 but never actually reaches it, so the vertical asymptote is x equals -3. Then your horizontal asymptote is y equals 1 because it's approaching 1 but doesn't actually reach it, and is approaching 1 but never actually reaches it. Then finally, you're going to find your end behavior, and this one is as x is approaching -infinity, y is approaching 1, and as x is approaching infinity, y is approaching 1.